Hello there, Mr. Sutton bringing you the AB Calculus 410 classwork solutions on derivatives of inverses. For this problem, f of x is 3x minus 5 and g is the inverse of f. Given that f of 4 is 7, we want to know the value of g prime of 7. So we're trying to take the derivative of the inverse. So we're going to use our inverse derivative formula. G prime of 7 is going to equal 1 over f prime of g of 7. So this is our initial setup here. So g of 7, that's the input to f when the output is 7, because g is the inverse of f. So if I get back 7 from f, I had to input 4. So g of 7 then is going to be this 4 input. So I'm really doing f prime of 4. So now let's go ahead and calculate f prime and plug 4 into it. Well, if f is 3x minus 5, f prime of x is just 3, the slope of that. So that means that even if we were plugging in something other than 4, no matter what we're plugging in, we just get 1 over 3 for the answer. For this problem, f is a differentiable function with f of 6 equaling negative 2, and all the rest of this information here. Function g is differentiable, and g of x is the inverse of f for all x values. Based off this, we want the value of g prime of 6. So since g is an inverse, its derivative is going to be 1 over f prime of g of 6. So this is our inverse derivative formula at work here. G of 6, that's going to be the input to f when the output is 6. So let's look for an output of 6 for the f function. We see up here f of 3 equals 6. So since 6 is the output, that means that 3 is g of 6. 3 is our input. So this is really going to be 1 over f prime of 3. Do we know f prime of 3? We do. It's 1. So this is just going to be 1 over 1, which is 1. For this problem, we have a table with some selected values of f and its derivative. If f inverse is the inverse function of f, what's the value of the derivative of f inverse at negative 5? So for this, we're going to use our inverse derivative formula. This inverse at negative 5 is going to be 1 over f prime of f inverse of negative 5. What is f inverse of negative 5? That's the input to the f function when the output is negative 5. So looking at my output column here, I see that I have negative 5 as the output when I plug in negative 6. So that means f inverse of negative 5 is negative 6. So we're really doing 1 over f prime of negative 6. Now f prime of negative 6, if you look in this row here, f prime there is going to be negative 4. So this is really negative 1 over 4. For this problem, f is a differentiable function, and we've got all this information about f and its derivative at various values. G is differentiable, and it's the inverse of f. Based off of this, what's the value of g prime of 1? Since we're taking the derivative of an inverse, we use the inverse derivative formula. G prime of 1 is going to be 1 over f prime of g of 1. What is g of 1? Well, that's the input to the f function when the output is 1. We see the output of the f function is 1 when its input up here is 12. So g of 1 is really 12. Now we need to find f prime of 12. Well, they gave us that right here. F prime of 12, they said, is 2. So this comes out to 1 over 2. On this problem, we have a table of f and its derivative at various values. If f inverse is the inverse of f, that sounds kind of funny to say, what's the value of f inverse prime of negative 3? So since we're taking the derivative of an inverse, we're going to use our inverse derivative formula. So this is going to equal 1 over f prime of f inverse of negative 3. F inverse of negative 3, that's the input to the f function when the output is negative 3. Looking in my output column here, we have an output of negative 3 when the input is negative 1. So this then is really 1 over f prime of negative 1. And f prime of negative 1 is 6, so 1 over 6. On this problem, f of x is equal to negative 1/6 x plus 3. G is the inverse of f. If f of 18 is 0, we want the value of g prime of 0. Since we're taking the derivative of an inverse, we'll use our inverse derivative formula. So g prime of 0 we can say is equivalent to 1 over f prime of g of 0. And then g of 0, well, that's just the input to the f function when the output is 0. We see here that when the input is 18, the output is 0, so that means g of 0 must be the input here, 18. So we've got 1 over f prime of 18. Let's figure out what the f prime function is algebraically. So here's f of x. The derivative of that is just this negative 1/6 slope of this function. So that means that f prime of 18 and pretty much everything else is going to equal negative 1 over 6. So this is really 1 over negative 1/6. And same change flip, we end up with negative 6. On this problem, we're given f of x equals radical 5x plus 7x. G is the inverse of f, and f of 5 is 40. Given all this info, we want g prime of 40. Since g is the inverse, we need the inverse derivative formula to calculate this. So g prime of 40 is going to be 1 over f prime of g of 40. And g of 40, that's the input to the f function when the output is 40. So that would be this input of 5. So we're really doing 1 over f prime of 5. All right, we have to figure out what f prime is doing. Here's f. To take its derivative, going term by term here, this is really 5x quantity to the 1/2. So this is going to be 1/2 times 5x to the negative 1/2 times a tail of 5. So we'll call that 5 halves, 5x to the negative 1/2. And next we have this plus 7x. So the derivative of that is going to be just 7. All right, let's go ahead now and plug in 5 to this expression. So this is really 5 over 2 radical 5 times 5, all of that plus 7. Well, this is really the square root of 25, which is 5. That cancels with the 5 up here, leaving us with 1/2 plus 7. And then that's really 14 halves, or 7 is 14 halves plus 1/2. So that's going to be 15 halves. Let's go ahead now and plug that in for f prime of 5. So this is really just 1 over 15 halves. And if we multiply by the reciprocal, that's going to come out to 2/15. On this problem, h is given by x to the 5th plus 3x minus 2. H of 1 is 2. And we've got h inverse here. We want to know the value of the derivative of h inverse of 2. To figure this out, we'll use our inverse derivative formula. So that's going to be 1 over h prime of h inverse of 2. What is h inverse of 2? Well, that's the input to the h function when the output is 2. We see here that the output is 2 when the input is 1. So this is h inverse is just 1 then. So we've got 1 over h prime of 1. All right, we need to see what the h prime function looks like. So here's h. Let's take its derivative now. That's going to be 5x to the 4th plus 3, and this negative 2 goes away because it's a constant. So we're really doing 1 over 5 times 1 to the 4th plus 3. That's really 1 over 5 plus 3, or 1/8. Choice B. On this problem, f of x is sine of x plus 2x plus 1. G is the inverse of f, whatever that is. And we want the value of g prime of 1. Since I'm taking the derivative of an inverse, I need the inverse derivative formula. So that's going to be 1 over f prime of g of 1. We need to find g of 1 now. That is the x value that's going to make f of x come out to an output of 1. So what value is that going to be? To figure that out, let me set this function here equal to 1. And this is going to be a tough one to solve algebraically, but just thinking about this logically, if we already have 1 on the right side and 1 on the left side, if I could find a value of x that made sine of x and 2x 0 at the same time, then I would have solved this equation. So what x value makes sine of x 0 and 2x 0? Well, there's only one thing that makes 2x 0, and that's 0. It also makes sine of x 0. So that means x equals 0 is an answer for this. Okay, so we're really doing then 1 over f prime of 0. Now we need to figure out what f prime is doing. If f is sine of x plus 2x plus 1, f prime is going to be cosine of x plus 2. So that means I'm doing 1 over cosine of 0 plus 2. Cosine of 0 is 1, so this is really 1 over 3, which gives us choice A. On this problem, f of x is x cubed plus x. g is the inverse of f, and g of 2 is 1. Based off of this, we want the value of g prime of 2. Since I'm taking the derivative of an inverse, let me use my inverse derivative formula. This is going to be 1 over f prime of g of 2. And what is g of 2? Well, before you go ahead and start looking for outputs of 2 and looking at the input there, notice that they already gave you g of 2 right here. It's 1. So this is just 1 over f prime of 1. What is f prime doing? Well, here's f. So f prime is going to be 3x squared plus 1 using our power rule. So this is really going to be 1 over 3 times 1 squared plus 1, or 1 over 3 plus 1, or 1 over 4, giving us answer choice B. On this problem, f and g are differentiable, and we're told that f of g and g of f are both x. Based off of that and the fact that f of 3 of 8 and f prime of 3 is 9, we want g of 8 and g prime of 8. So the key here is realizing that based off of these two equations here, g is f inverse, which means that if I'm taking the derivative of g, I need the derivative inverse formula, which is going to be, in this case, 1 over f prime of g of 8. Okay, well, what's g of 8? That's the output, or the input rather, to the f function when the output is 8. When the output is 8, the input was 3, so that means that g of 8 is 3, which means this is going to be 1 over f prime of 3. And f prime of 3, they told us, is 9, so this is 1/9. So we've got g of 8 equals 3, g prime of 8 equals 1/9. That's choice E. On this problem, f is defined as 2x plus e to the x, and g is the inverse of f, and we have the point 0, 1 is on the graph of f. Based off all this, we want the value of g prime of 1. Since we're taking the derivative of an inverse that they said here, that means we need the inverse derivative formula, which in this case is going to be 1 over f prime of g of 1. Well, what is g of 1? That is the output for the f function, or rather the input for the f function when the output is 1. We see here, based off of the point 0, 1, that when the output to the f function is 1, the input was 0. So this is really asking for 1 over f prime of 0. What is f prime? Based off of this formula, that's going to be 2 plus e to the x. So here we're doing 1 over 2 plus e to the 0. E to the 0 is just 1, so this is really 2 plus 1, or 3. So then 1/3 would be our final answer, choice B. On this problem, we're given a table of values for f and its derivative at various x values. Based off of this, we want to know the derivative of f inverse at 2. Since I'm taking derivative of an inverse, I need my inverse derivative formula. So this is going to be 1 over f prime of f inverse of 2. What is f inverse of 2? That's the input for f when the output is 2. F of x is my output column, so when I have 2 in the output column, the input was 1. That means f inverse is 1, which means we're doing 1 over f prime of 1. What's f prime of 1? Well, looking in this 1 row here, f prime of 1 is negative 8, so this is negative 1/8, which is answer choice B.